Using Connect visualization services, the reliability engineer can bring it all together, creating rich dashboards of both engineering and operations data, which can be shared throughout their company. All the relevant data that they need to ensure optimal operation of their wind turbines is made available right here in these cloud dashboards, which even can offer native AI assistance for investigating and analyzing this data, using AVEVA's industrial AI assistant. The engineer can ask straightforward, natural language questions about their data, here investigating deviations between expected and apparent power, and have the AI assistant return both calculated results and helpful context regarding the response. Altogether, with the Connect industrial platform, the reliability engineers company can easily and securely explore AI and predictive analytics, monitor their remote assets, increase their efficiency, and drive their company's digital transformation.
The monitoring and diagnostics team can see an overview of their pipeline operations. They view geographic locations of their pipe networks, alongside key KPIs such as pump reliability. The monitoring team can drill down into the performance of each pump station and view its related pumps. They can instantly see that one pump is underperforming, as it is highlighted in red. This is related to the asset having a high overall model residual, which is an asset health indicator. They note a deviation from normal operating conditions. The deteriorating pump health is shown on this screen as the purple overall model residual trend. They can also view additional information provided by IoT sensors to understand more about the pump condition. Based on the behavior of these values, the top 2 likely fault diagnostics are pulled in from Predictive Analytics. Opening AVEVA Predictive Analytics, the monitoring and diagnostics team dive deeper into the faulty pump. Here, they access the overall model residual trend and all signals associated with the pump. Each signal from the asset is plotted against its predicted value and drives the overall model residual. This enables the team to quickly identify any anomalies. The monitoring team easily views which signals are the leading contributors to the asset's high overall model residual value. In this case, the highest percentages of the OMR are all associated with motor thrust bearing temperatures. By selecting one of the sensors, they view the deviation of its values from a predicted state. The team can also access fault diagnostic information which presents the most likely reason for the alert, allowing them to communicate to the on-site maintenance team that the bearings have overheated. They can prescribe inspections and further actions to aid the maintenance of the asset by drilling down further into the fault. They can then view the next steps as well as user-defined properties, which helps the team to categorize the fault or offer additional risk analysis. Additionally, the monitoring and diagnostics center team can view the relationship between fault condition, fault diagnostics, and fault signature for a specific project. Using this fault tree, they can see that the top contributors to the overall model residual also matches the information shown in Pi Vision. The team performs a forecast analysis to help predict how many days the asset has left until failure, unless maintenance is performed. Through this, the team determine that there is less than 1 day runtime of the asset, with a 70% probability that a breakdown will happen within this time. The monitoring team decides to raise a new case from the trend of the early warning alert and assign it directly to the maintenance team for further investigation. Within the case, the monitoring team inputs the information they have just noticed from the previous investigation of the alert, including details and diagnostic information, stating here that it could be an upper bearing coolant flow issue. The team also starts a discussion thread, giving everyone involved full visibility of the history and progress on the resolution of the issue. Here, they request that local instrumentation and coolant strainer are checked by the maintenance team. The maintenance team will open the assigned case, and will add their comments after they have completed their on-site inspection. It appears that the cooling strainer may be plugged, and the team should switch to the backup coolant strainer. The monitoring team works with the maintenance team to find the best scheduled outage of the equipment. Later in the day, after maintenance has been completed, and the pump bearing cooling system been repaired, things are back to normal. The on-site maintenance engineer returns to the pipeline overview screen to see there are no underperforming pumps. Then monitoring and maintenance teams must fill out resolution details within the case, such as fault condition, impact, and the related savings, based on user-defined calculated estimations. The maintenance crew logs that they swap the bearing coolant strainer, and confirms that the upper bearing coolant flow signal has returned to normal operating range before any costly damage was caused, and without a critical shutdown.